Okay, welcome to Wednesday's class. I know I didn't stream yesterday, but hopefully you're catching up on your assignments. I know a few of you have been in contact with me for the last couple of days wanting to get some work done, so that's awesome. Just keep reaching out to me on email, and I'll keep sending you your tests and assignments. Yesterday, I uploaded the solutions to lesson 6, assignment 6, volume and surface area of irregular shapes. So they were just kind of, in some ways, different looking shapes, but these were more everyday shapes that you might see, like a straw. And just getting you to realize that a straw is a cylinder with no ends, right? Or an aquarium. Aquarium is just a rectangular prism without a top. So that's kind of interesting that there's shapes all around us that maybe you never really realized that we could study in the math classroom. But hopefully now you're looking at the world with new eyes, right? And also maybe appreciating what you learn in math class a bit more. So lesson 7 is surface area and volume applications. We were sort of doing that yesterday, but these are actually going to require a little more thinking even. They're more like the last question about the dreidel on the previous assignment. So if we read the text here, as with two-dimensional areas, surface area and volume are concepts that are constantly used in the real world, in our everyday life. Surface area is used in applications where you need to find an amount of material, for example, wrapping paper, paint, plastic, that will comprise the outer shell of the shape being manufactured. Volume is when you need to determine the amount of material that will completely fill the inside shape. So surface area is the material made to build something, and volume is the surface area of stuff that you put inside. These application questions will commonly require you to figure out which concept is needed, surface area, volume, or possibly both. There may also be a cost component to the question. Recall that when adding tax, the rate of PST and GST combined is 7%, combined is 12%. So just remember that in Manitoba currently, 7 plus 5 total Manitoba tax. Okay, let's take a look at this first example. You have a large present you need to wrap in fancy wrapping paper. It is a snow blower in a box with measurements shown in the diagram below, so quite a large box. 4 feet wide, right? That's what we commonly call the width. Length would be 5, and length is defined as being larger than width if the base is not square. The larger number will be the length. This is the width, and this is what we usually refer to as the height. You will need 10% extra wrapping paper to have enough to overlap, right? That's your, usually when we're building things or wrapping things, we like to have a bit extra. You want to wrap the box in wrapping paper that costs $5.99 plus tax. That means I have to add that 12% in. Each roll covers 50 square feet. So I've got all my numbers highlighted so I don't forget them. Calculate the cost of wrapping paper. So this is to cover the outside of the box. It has nothing to do with inside it. So we need to use surface area of a box. Fancy name is the rectangular solid, right? If you look at I always just have my formulas kind of at the ready. So technically it's called the rectangular solid, but it's everyday language, it's the box, right? So I need the surface area, so I need this formula, and I need the whole thing, right? So 2 length times widths, 2 length times heights, and 2 width heights. I need the whole formula because I want to wrap every side of the box. There's no side that's left unwrapped. All right, so that's easy enough to do. So I have 2 times 5 times 4. They're all in the same units in feet. So I don't have to do any conversions. All right, I'm going to pick my calculator up and do this big, long math. And I get 112. I'm just going to do that one more time just to make sure I typed everything in. Okay, so 112. So I have to add 10%. We need 10% extra paper. So I'm going to take my 112. And if I just wanted 10%, what is 10% of 112? Well, what is 10%? Just 0.10, right? But if I want to subtotal, if I want to add it back to the 112, I'll just add a little 1 here. And then we'll do my subtotaling. So I'll need 125.44 feet squared. Okay, so this is what I need in total. Let's see, each roll covers 50, so I need 125.44 feet squared. Each roll covers 50 square feet, right? So if each roll covers 50 square feet, if I just divide by 50 square feet, because this is an easy enough one to do, right? Divided by 50. So I need 2.51 rolls. So you must go and buy 3. So this is an important concept in the applications. You can't go to the store and buy 2.5 rolls. So you must buy 3 rolls. That's where applications require a little bit of common sense too, right? So 3 rolls times 5.99. Okay. So this is going to be my subtotal, right? Now also I have to add the tax in. So if I just add the tax in and to find the tax itself would be 0.12 for 12%. But I want to do my subtotaling. So I'm going to do everything at once, so I only have to round at the very end. The less rounding you do, the more accurate you are. So I will get $20.13. This is what I get when I multiply all this together. 126, so that would round to 13. So just for the paper, this is the cost to wrap. So what did I have to do? I had to recognize the shape, recognize that I'm going to be using my surface area formula, and then do all the adding up and adding taxes on, right? So don't forget taxes are 12% until we're told otherwise. Next example, example 2, a company manufactures beach balls made of plastic filled with air. The ball is a sphere. Okay, that's nice that even if they didn't give it to me, I would know that's a sphere with a diameter of 20. So as soon as I see diameter, no, none of my formulas do diameter or use diameter. So I'm going to quickly state that the radius is 10. How much plastic would be required to manufacture the beach ball? So that's an outer, that we're talking about the outer surface. So surface area of a sphere, you can spell that. Spelled sphere wrong, is 4 pi r squared. Okay, so that's easy enough to do. Surface area equals 4 times pi times 10 squared. So that's going to equal 1256.64. So if I look at my units, centimeters squared. Okay. How much air would be needed to fill? Okay, air goes inside the sphere, so we're talking about volume. So I'm going to flip to my volume on page 30. So I'm looking at the volume formulas. Volume of a sphere is 4/3 pi r cubed. So volume of air will be 4 divided by 3. That's what 4/3 means. Times pi times 10. That's the radius, right? Power 3. And make sure you know where your exponent button is. You should know where that is by now. And I get 4188.79. Now, volume is always meters cubed. And then finally, if plastic costs 0.002 cent or $2, so that would be like 0.2 cents per centimeter squared, how much plastic costs for the beach ball? Okay, so here's I need 1,256.64 centimeters squared. Each centimeter costs this, so this is just being multiplied. Now I could use the cross multiply method, but I think this is straightforward enough that I could use the quick way. But if you want to use this cross multiply method that we learned in lesson 1, go right ahead. So this is going to cost $2.51 for the plastic. All right, if it costs that much for one beach ball, how much will it cost for 100,000? All right, well, I guess $2.51 times 100,000. Okay, so 251 times 100. 251,000. All right. So once again, this time we had to use surface area and volume because it was a multi-step problem. So anything referring to the outside covering of an object is surface area. That's the materials to make it. Volume is what goes inside. Last example. A hardware supply factory makes washers. So those are little things that go on a threading on a nut, like a nuts and bolts. A washer is a small metal disc placed between the head of the bolt and the nut the bolt is going to be inserted. It kind of provides a little layer of protection. Each washer is 1 millimeter thick. So that's like the height, right? The diameter is 15. So these are all the important numbers, right? We've got 1 meter thick, diameter is 15, radius of the hole is 7. Determine the amount of metal required to produce 1 million washers. Okay, well, let's see. I'm just going to blow this up a little more over here, right? So I see, all I want is, if I think about this, I want the shaded part, right? Exactly like the picture is here. So I just want the shaded part. So what do I have to do? I have to find the area, find the surface area of 2 cylinders, because amount of metal is surface area, right? Amount of product of 2 cylinders. If you think about it, I want the large cylinder, like I want to pretend that this whole thing is just made of plastic or of metal. So that's the large cylinder. And then I'm going to pretend that this little cylinder in the middle, just made of nothingness, is a cylinder of just space and air. It's a cylinder of air, and that's the one I want to subtract out. Subtract large cylinder minus the small cylinder. Will give you equals surface area of shaded part only. Right? So I just want this shaded part. All right, so surface area of cylinder, that's actually an easy formula. Fairly easy. So surface area of cylinder equals 2 pi RH and 2 pi R squared. Okay, so let's see. The surface area of the large cylinder equals So the whole diameter all the way across this, diameter is 15. So the radius will be 7.5, half of 15. Okay, so 2 pi 7.5, and then the height equals 1 millimeter. Because if it says thickness would be height in this case, plus 2 pi 7.5 squared. All right, let's see what we get here. Wants to type into our calculator, 2 pi times. So I get 400.55 millimeters squared. Now, this is the amount of metal I need for a disc without this hole. So now I'm gonna, the small cylinder, which is the hole. Okay, so same thing, but it says the radius of the hole is 7 meters, so the radius changes, right? So I have 2 pi times oops. I think I forgot that one there. Sorry. Oops. I'm just going to type this over again to make sure I got the right answer. Sorry, I'm going to do this one more time just to make sure this one is right. 2 times pi times 7.5 times 1 minus 2 times pi times 7.5 squared. Something's going wrong here. 2 times pi times 7.5 times 1 plus 2 times pi times 7.5 squared. Yeah, so that's correct. I just forgot to add the little 1 here. So I have 2 times pi times r, the radius of this hole is 7, times 1, because it's still the same depth, plus 2 times pi times the radius squared. So I'm going to type all this in. It's just slightly smaller, right? And I get 351.86 millimeters squared. So this would be, this is the amount of metal for the whole disc. This is the amount of metal that would have been inside the hole. So I'm going to subtract these. Surface area of the disc equals 400.55 subtract the whole. And I get 48.69 millimeters squared of metal needed. Okay. So what did these examples do for us? Well, we practiced surface area with a shaded part, right? Removing a part. Example 2 was surface area and volume of a shape. And example 1 was just surface area, but it did have money with taxes. So it gave you exposure to how to add taxes in. So I'm going to leave that with you today. I'm going to end the video, and I'm going to get you to work on assignment 7, which is another big one. And then we have just scale, which I think I'm going to talk about on tomorrow. And then that's it for the course, everyone. So please keep me apprised. We'll have everything finished up. Friday is our last day of classes. So if there's anything you need, you want me to say or you want to give me in terms of work, it has to be submitted by Friday. So that's it. I'll talk to you over email and try and get as much as you can done of assignment 7.